Hello all, my name is Chinmay Deshpande and today we are going to discuss concept of serial communication and UART in Arduino UNO IDE. Objective of this video is, after studying this video lesson, you will be able to understand the concept of serial communication and its types, concept of UART, that is Universal Asynchronous Receiver Transmitter, meaning of the functions associated with serial communication. Let's understand first what is a serial communication. Communication is nothing but it is exchange of information between two devices. Here the information is nothing but a data which can be anything like a text document, images, audio or video files, etc. Data can be sent or received between two systems or devices, and it is in the form of bits, that is zeros and ones. So computer understands only a binary language, that is zeros and ones. The main purpose of this serial communication is to transfer the sketch, that is a program, from computer to the Arduino, send the information to the computer, etc. Here the word serial means one after another. Today most Arduino boards are built with several different systems for a serial communication as a standard equipment. Which of these systems are used depends upon the following factors. That is, how many devices the controller has to exchange the data with, how fast the data exchange has to be, what is the distance between these devices, and is it necessary to send and receive the data simultaneously. So the serial communication provides an easy and a flexible way for your Arduino board to interact with your computer and other devices. The information passes between the computer and the Arduino through USB cable. The information is transmitted as zeros and ones, which is also known as a bit. The most common type of serial communication protocol is UART, that is Universal Asynchronous Receiver Transmitter. So let's discuss what is the concept of UART. Arduino has built-in support for UART which enables a serial communication. Let's take the example that when I press a 5 from a keyboard, my LED should glow connected to the digital pin of Arduino. How is it possible? There is no keyboard on the Arduino. So how to do it? By using serial communication. UART or UART, that is Universal Serial Asynchronous Receiver Transmitter, is a serial communication protocol that can be used to transmit or receive a data serially at a specific baud rate. Let's discuss baud rate in the next slide. The Arduino can transmit and receive the data to the PC over USB cable. This comes handy when we want to send the sensor's data from controller to the PC. The Arduino IDE has built-in serial monitor window. So this is what is a built-in serial monitor window. It displays the data sent from the Arduino to the PC. The same way we can send data or a command from serial monitor to the Arduino. The serial communication enables us to control the electronic devices connected to the Arduino board from the PC. Let's discuss types of serial communication. First is synchronous serial data communication. Second is asynchronous serial data communication. So in a synchronous serial data communication, devices that are synchronized use the same clock and their timing is in synchronization with each other. Whereas in case of asynchronous serial data communication, devices that uses different clock sources for a transmitter and receiver, a process operates independently of other process is nothing but asynchronous. Now in this mode, data is transmitted with start and a stop bit. So therefore here the data transmission, here I have written a start bit, this is your stop bit. Asynchronous communication means each character, that is a data byte, is placed in between the start and stop bit. So whatever bits which are present in between start and the stop, basically it is nothing but a data. Now there are 1, 2, 3, 4, 5, 6, 7, 8 bits. 8 bit is nothing but 1 byte. So therefore asynchronous communication means each character, that is a data byte, is placed in between start and stop bit. The start bit is always 0, so therefore this is what is your 0 magnitude. Stop bit is always high, so that is it is magnitude 1. In asynchronous serial data communication, single byte is transmitted at a time. Arduino UART. Arduino UNO Atmega 328 has an inbuilt UART which is useful for serial communication. It can be used to communicate data between PC or various serial devices like GSM, GPS and Bluetooth etc. The UART protocol allows for two devices to communicate with each other. The protocol requires two wires between the devices that are communicating and one for each direction of a communication. Each device has an independent transmit and receive module. For two devices to communicate with UART serial, three wires have to connect them. The first two are communication wires. The transmit, that is TX of the first, has to connect to the receiver, that is RX of the second. And the transmit, that is TX of the second, has to be connected to the RX of the first. Means there has to be a closed loop. The third wire is the ground. The devices have to have a common ground reference. So now if you observe here for Arduino, this side is nothing but your digital side. We already discussed this point. But if you observe here, this is your D0. What is written here? R into D or RXD. This is what is your digital pin 1. What is written here? TXD or T into 1. So Arduino communicate with serial devices over digital pins 0, that is RXD, and 1, that is TXD. Whereas it communicates with PC and laptop with the help of USB. Now if you observe here, it consists of two LED indicators. First is TX, second is RX. TX and RX are also highlighted in a diagram, which are status LED used to indicate a serial transmission and reception with respect to Arduino board. So let's discuss how it operates. Whenever the PC transmits data serially to the Arduino UNO over a USB. Now carefully understand this concept. PC transmits data. Suppose I am talking about with respect to Arduino board, then what? It is going to receive the data from the PC. So whenever Arduino board receives the data from the PC, RX LED glow to indicate data is received. So this is what is your RX LED will glow whenever the PC transmits data to the Arduino or Arduino receives the data. On the other hand, whenever Arduino UNO transmits data to the PC over a USB, now Arduino UNO is going to give a value or going to give a data to the PC, means it is going to transmit the data. So therefore in that case, TX LED glow to indicate data which is transmitted. So this is what is your TX LED. This is a concept of Arduino UART or UART. Next we will discuss the baud rate. But before that, understand this very important concept. In case of Arduino UNO, simultaneous serial communication over USB and RX TX pins are not allowed. Okay. Now let's understand what is the concept of baud rate. The rate at which the bits are transmitted is called as baud or a transfer rate. The baud rate is a reciprocal of a time to send one bit. Serial communication occurs between Arduino and a computer or a serial devices at the same baud rate like 4800, 9600, 115200, 34800, etc. So it is bits per second BPS. Okay. If you have a broadband connection, you may remember reading somewhere that it has, say, suppose 350 kbps download rate. This is how fast the connection can read and write the bits on the wire. But obviously your broadband connection can transfer data a lot faster than the Arduino. Okay, so this is what is the example that I have given to understand the concept of a baud rate. So if you observe here, this is what is your serial monitor window, and whatever portion which is highlighted here, one can change the baud rate by selecting one of the value highlighted in the image given. If the baud rate of two devices mismatch, then we will get nothing or we will get a garbage value. Let's understand the first function associated with serial communication, that is serial.begin. Now as the word present is .begin, begin means what? To start. So this function is used to begin the serial communication and also set the data transfer rate for a communication, that is a baud rate. So syntax for this is serial.begin baud rate, where that baud rate indicates how many bits we are going to transfer in a 1 second. The units of a baud rate is bits per second, that we already discussed in a previous slide. It is BPS, and we also discussed the common values of a baud rate as 9600, 19200, etc. The preferred baud rate in most of the devices is 9600 BPS, and the default value in Arduino serial terminal is also the same, that is 9600. In the sketch or a program, we will initialize the serial communication by writing the function serial.begin 9600, and it has to be written in a setup function, that is void setup function. So what is the meaning of serial.begin 9600? It defines a 9600 baud rate for a serial communication. Now let's discuss functions which are associated with transmitting the data with respect to Arduino UNO. So there are three functions associated with the transmission: serial.write, serial.print, and serial.println. So first we will discuss serial.write. What is the description of serial.write? This is the simplest output command. It is used to write some data on the serial port, and it sends the data in a binary form. It sends only one byte of a data at a time, a single value of 0 to 255. The input to the function can be defined with a numerical value or with a character in a single quote. Suppose if I want to give only a character, I have to write within single quote. And we can also give a string, but I have to write it within double quotes. This function writes your binary data to the serial port. So this is what is the syntax. Serial.write, I have written VAL in single quote. That VAL, it might be a value to send as a single byte. It is used in the character, or it is used in a single quotes. So let's take an example. Suppose if I write serial.write in a single quote 1, then it will send the byte 1 on the serial port. Now as I discussed already, we can also send a string of a byte via Arduino serial write command, but for that syntax is same. You have to write it within double quotes. So suppose if I want to send, or if I want to write my name serial.write Chinmay, then it will send the name Chinmay on the serial port. Okay, so this is what is the concept of serial write function. Next is serial.print function. Now as the name suggests, print means it will print the data. So this function is used to print the data to a serial port in a form that is a human readable. So the data might be a character, single letter, or a string. Set of a character means any sentence or a number. So syntax for this is serial.print value format type. Now whatever format type I have written in a syntax, it is optional. There is no need to write it always. So where that value indicates character or string or a number to be printed. So suppose if I have written within a double quotes the number is in a serial.print function, then it will print the sentence the number is. Suppose if I want to print only a number, then there should not be any double quote or single quote. So when I write serial.print 123, it will print the number as 123. In order to print only answer or number, do not give single or double quote. Next is serial.print 1.23456. So it will print as a 1.23. Okay. Again, if I want to print the number, there will not be any single or double quotes. Let's discuss few more examples. Serial.print n, it will print as a n. Now suppose if I write serial.print 78, bin, bin means binary. So it will convert your number 78 into the binary, that is 1001110, and that binary number will be displayed. Next is serial.print 1.23456, 0. So it will print only a 1, that is number before decimal place. Serial print 1.23456, 2. what it will do? It will print only 2 digits after decimal point. So it is 1.23. If I modify these and I write here 4, then it will display but obvious 1.2345. Next is serial.print in a double quotes /t. /t is nothing but a tab, means some space will be provided. We use that tab in our keyboard, so the same function this /t does. This is what is serial print function. Next is serial print ln function. Now basically serial.print and serial.println both are same, but the difference is that this function is used to print the data to a serial port in a form that is human readable. It might be a character, string or number, but it followed by carriage return /r and a new line character, that is ln/n. So that ln indicates that new line. What is carriage return? Carriage return means to return to the beginning of a current line without advancing downward. So the syntax for this is serial.println value comma format type. Again the format type is optional. Value might be a character, string or a number to be printed, that we discussed already. Let's take one example. Suppose in a void setup I have taken baud rate as 9600, and in a void loop, suppose if I have written in a serial.println hello word is written and delay is given. So what will be the expected output? The expected output will be, it will print first word hello, then as ln is present, the cursor will go to the next line. After 1000 delay, it will print again hello. So continuously it is going to print the word hello, hello, hello. This is what is serial.println. The basic difference is that both will print. Serial.print also prints the sentence or number. Serial.println also prints the sentence or the number. But the ln which is present, it followed by the carriage return or a new line. That is, the cursor will go towards new line. Now let's take one example for understanding these instructions that we discussed earlier. I have three variables A, B, C having integer data type, and I have taken few numbers 5, 15 and 20 within each. So I have defined this. In a void setup, serial communication 9600 bps, that is baud rate is given. Now here I have written serial.println. Here is a sum map. Now what will be the output for this? It will print the sentence, here is a sum map, and it will go to the next line as ln is present. Next is serial.print a equal to. So what it will do? It will simply print a equal to and serial.println. Now whatever will be the value associated with a variable a, it will be print. So a equal to, it will print a equal to 5, and after that it will go towards the next line. So similarly on the next line it will be b equal to 10. So this is what is your output, a equal to 5. Now as ln is present, after number, whatever number which is there, it will be print and then it will go to the new line. So therefore it will go to the new line. Again b equal to 10, it will go to the new line as serial.println b is written here. Now suppose if I want to add these two numbers, so I can write here a plus b equal to, so it will print a plus b equal to because of serial.print and serial.println. Now what it will do, a plus b, there are no double quotes or there are no single quotes are present, means it will handle a number. So 5 plus 10, it will be a 15. Now as here ln is present, it will go to the next line. So likewise this program executes. Let's discuss functions associated with receiving the data with respect to Arduino UNO. So we discussed how to transmit the data. Now here we are going to discuss receiving the data. So the functions are serial.read and serial.available. Now what is serial.read? As in the word itself, read is present. What is the meaning of read? It reads the incoming serial data received on a RX pin of Arduino. So the syntax for this is serial.read. Suppose if I have say instruction is received underscore data equal to serial.read. So whatever a value which will be read by the function serial.read, it is going to stored in the variable having a variable name as receive underscore data. Next is serial.available function. This function is used to get the number of bytes, that is a character, available for reading from the serial port. This is the data that's already arrived and stored in the serial receive buffer. So I want to check whether the data is available or not. So for that case, this function is used, that is serial.available. This is what is the syntax for that. Next is serial.end. Suppose if I want to stop a serial communication. If I want to begin it, I have written serial.begin. If I want to stop it, I have to write serial.end. So it disables the serial communication, allowing the RX and TX pin, that is D0 and D1 pin of Arduino UNO, to be used for a general input and output. If I want to re-enable a serial communication, again I want to call serial.begin here. So this is what is the syntax for serial.end. Let's discuss algorithm. In a setup function, initialize the serial port with desired baud rate, say 9600. Second one is transmit the initial message. Suppose if I want to write a sentence, serial communication, then I want to transmit this message, initial message, in a setup function. Now in a loop function, declare the variable with data type integer to hold the received data. Check for any data received for a serial port. So when I want to check whether data is received or not, I have to use here if condition. If the data is available, then it is going to store in a variable, and if it is not, then wait for data available. And if it is yes, read the data into a variable and retransmit the data on a serial port. Let's discuss the sketch or the program here. But obvious, the first step is void setup. The setup function runs only once. Here I have defined the 9600 baud rate for a serial communication by the function serial.begin 9600. Now I want to print a statement serial communication demo. So I have written it within serial.print, and the ln is used because after printing this statement, your cursor is going to move to the new line. Next, again serial.println, please send a data. So the meaning of this is again same. It will print the statement please send the data, and the cursor will move towards new line. This is what is void setup function. Now in a void loop, what is the meaning of a void loop? The loop function runs over and over again forever for a continuous period of a time. Now I want to check the condition whether the data is received on the serial port or not. So I want to check whether it is available or not. So it can be checked by the function serial.available. If it is yes, if answer for this is yes, then what I want to do? I want to move that data which is available. I want to read that data by using serial.read function, and whatever data is there, I want to store in a variable. The name of variable is in byte, and it is of integer data type. Okay. Now next is serial.write in byte. Means it writes the data present on in byte variable to the serial port. So this is what is program of serial communication. Thank you for watching this video.